Video Lecture 3.8, Water Vapor and Clouds. This whole entire video lecture 3 is supplemented with a discussion which I'll use various videos to visualize the atmosphere in motion, and trust me, these videos kick ass as far as what they can show us. But what we're going to be looking at is water vapor. And so what you're looking at here is all water vapor at one moment in time on Earth. Let's get through some key terms that we're going to use when we further describe weather in video lecture 4. What is humidity? It's the amount of moisture in the air. We look at two key things. First off, the dew point. The dew point is the temperature at which air becomes fully saturated. And so anytime you see the dew point temperature equal to the air temperature, when they're the same, we've got 100% relative humidity. So essentially the moral to the story is when the dew point temperature, whether it's Angela Buckman or whoever, when they mention the dew point temperature, when that dew point temperature is very, very, very close or equal to the air temperature, that means it's quite humid. That means it's probably raining outside. There's a good chance that we have precipitation. So that's the key point here is with dew point, when we think of it, how close is it to air temperature? That is an indicator of humidity. Relative humidity, what is it? It's a percentage. So when we describe relative humidity, we describe it as a percentage. 80%, 70%, 90%. And essentially all that is where we find that, it's the amount of water vapor in the air divided by the amount of water vapor that air can hold. It can only hold so much. If not, then we're going to get condensation, precipitation, and it's going to eventually fall back down. So relative humidity, when it's 100%, we have precipitation. Pretty much for the most part, we can say that the amount of water that we have on Earth today is going to be, it's the same amount. It doesn't really change as far as how much water we have. It just purely changes its state. So this here is the hydrologic cycle. Hydrologic cycle is something you should have learned sometime in your K through 12 education. But the simple idea here is if you already know this, then just move along. But what we have here is water moving in a system, moving in a cycle. So we have obviously a good amount of water body on Earth's surface, oceans, and then we get a good amount of evaporation accordingly. So eventually that evaporation is going to create water vapor that's going to become held aloft, and eventually with wind, as we have learned beforehand, will now move that water vapor onto the surface, and so maybe we can get precipitation once we get to a high enough elevation where eventually condenses, cools, falls back down as rain, and that water then works its way through the ground, might matriculate through the underground surface, or collect in a stream, a river, a creek, whatever, and then eventually head back down to the ocean, a bay, a gulf, whatever. Also trees take in water, and then they perspire on their leaves water as well, another way in which water moves through this system. Of course, we can get evaporation also on the surface as well. And so rivers, lakes, what have you, also have evaporation. So water just constantly is moving as a system through all these various parts and processes. What a beautiful place we get to live. We live in a place that's just far enough to a star, the sun, that we have water in all three phases. Water as a solid, liquid, and gas. Here we see as ice as a solid. Of course, where we all wish we were, the beach. Here we can see, obviously, water as a liquid. And finally, clouds, which is an example of water as a gas, water vapor, which are the focal point of the remaining part of this discussion. We'll start off with our dust statement regarding clouds. It's essentially a grouping of small moisture droplets and ice crystals that are suspended in air, that are held aloft. Another way to describe that, to the point where actually they're visible to the human eye. Like I've said before, in this course we describe various physical phenomenon based on different criteria, different characteristics. For instance, wind, speed, and direction. For clouds, we're going to describe them based on their altitude and shape. First off, altitude, we've got those that are at the high levels, up at the top, or near the top of the troposphere, those that are closer to the middle, and then those that are closer to the surface, those that are lower. We have one that actually grows and develops through all three. It starts off low and then grows vertically up over time. In terms of shape, we've got three different key characteristics. We've got flat, puffy, and wispy. Flat are those that develop horizontally. Essentially, the entire sky, from one horizon to the other horizon, is just nothing but clouds. And so on those days, in which the entire sky is clouds. That is a flat, characteristic flat shape. Puffy ones. If I was to ask you to draw a cloud on a white piece of paper, oftentimes you would draw just one single cloud. That would be a puffy cloud, a cumuliform cloud. One of the characteristics are cumuliform clouds. They can be the ones that develop vertically through all three layers of the altitude, the three different altitude levels. Finally, we have the wispy ones. We'll look at examples of this. And so if I had a nice brush, an artist brush stroke, in which I was just kind of very gently moving my hand up with my paint, I would be doing this gentle brush stroke illustrating a wispy cloud. If you don't know what I'm talking about, you'll be able to see it in a following image. First characteristic of a low cloud is a stratus cloud. A stratus cloud is flat, featureless, dull. And so on these days, it's essentially the entire sky is one big cloud. Key, though, it doesn't mean it's raining. And so we have those days in which the entire sky is one cloud, but it doesn't mean it's raining. This is a way to illustrate a stratus cloud. We don't have precipitation. This is just merely dew that's forming on this vegetation. It's not rain. And so here we can see a stratus cloud. The next type of low cloud is a nimbostratus cloud, a stratus cloud with drizzling rain. So this is very much similar, which the entire horizon is one cloud, but this is going to be a little bit grayer in color, grayer indicating precipitation. It means it's raining. So here we might see a nimbostratus cloud as off in the distance we see precipitation. Finally, a cumulusCloud, which is also a low cloud, and this is going to be those bright, puffy, white cotton ball types of clouds. This is a very good indicator that we have fair weather. And here are some cumulus clouds. Next up are these StratocumulusClouds, and these are small, lumpy, grayish, low-level clouds. And they essentially kind of line up. They start to line up over the course of an afternoon. So they often appear at the end of the day, particularly actually in the fall. Here in Indiana in the fall, we often have stratocumulus clouds that develop in the afternoon. And here you can see these stratocumulus clouds. They're cumulus in the sense that they're kind of puffy, but you can see how they start to line up. They're kind of parallel to each other. So over the course of the afternoon, you have this predictable in Indiana. These predictable cloud types, these stratocumulus clouds, on an average weather day. It's not always when we have heavy rains are we going to see stratocumulus clouds, but in the afternoon, this is very typical to see in the sky. The middle level cloud that we're going to look at is the Altocumulus sky. Altocumulus sky. Characteristic is it looks like it's also known as a mackerel sky. It's got these small, puffy, higher clouds. Cumulus, as the name implies, means it's going to be puffy. But key, why am I talking about this one? Whenever you see the Altocumulus clouds in the sky, pretty much is a dead giveaway. We're going to get some storms coming. Here are Altocumulus clouds, small, white, puffy, and this is a dead giveaway that we got some bad weather coming. Here's another illustration of a Altocumulus sky in which you see those small, little, white, puffy clouds that are higher up in the sky, not at the low level, but found there maybe more at the middle level. There's an old sailor saying, mackerel sky, not 3 days dry, illustrating that this is once again an indicator that stormy weather is coming. Next up, the high clouds. The cloud that we're going to look at is a cirrus cloud, in which it's feathery looking. It's often found, as the name implies, way up high in the sky. Here's an image from the Google that I got that shows a cirrus sky characteristic pattern. And here's one I actually took. And so these are illustrating cirrus clouds that are found way up high in the atmosphere. But once again, they have a purpose, and we're going to build on that in video lecture 4. Next up, we have the cloud type that develops through all three levels. This is the big bad giant of them all, the cumulonimbus cloud. So this is a nice little happy white puffy cloud, cumulus cloud, that over time starts to get angrier. And as it gets angrier, it gets bigger. When it gets bigger and bigger and bigger, it even has even more energy and produces even a heavier storm. So cumulonimbus cloud, these are going to associate with severe weather, lightning, heavy rain, tornadoes are often corresponding with cumulonimbus clouds. And here's the big bad giant, the cumulusCloud, which in this image was just a nice happy white puffy cloud that over time became much bigger and bigger and bigger and developed vertically. It grew upwards in this image here. And here's an image from the National Geographic which really showcases that vertical development, how this cloud develops and grows upward. But then we have that anvil shape. If you don't know what an anvil is, Google it, A-N-V-I-L, and look at the anvil, the shape of one, and you're going to find that characteristic here. In a future video lecture 4, I'm going to describe, well, how does that anvil shape, why does it form, in which the top actually starts to build outward, builds up, but also builds out. We'll explain that in video lecture 4.